Hi, I'm Robert Bergman. I'm Professor Emeritus of Chemistry at UC Berkeley, and I'm pleased to be able to interview Professor William Lester, who is Professor Emeritus of Chemistry as well, and furthermore an old friend. We've been in the department for a long time together. So I'm going to start the interview by first introducing Bill and asking him a little bit about growing up in his early years. One of the nice things about this is that we both grew up in Chicago about the same time. And so I'd like to start, Bill, by asking you to say a little bit about your early years in Chicago, the influence of your parents and grandparents, and basically how you got started with your interest in chemistry.
Oh, okay. Yes, I'm from the south side of Chicago, which I think differs from you, Bob. Am I correct?
Actually, I was on the south side too.
Oh, okay.
We were in very different environments.
Yeah,
right?
okay. So basically, I started in Woodlawn. That's 100 or so south. This is slightly southwest of the University of Chicago. And growing up there was fascinating, and in retrospect, it was interesting to perceive my parents and grandparents in the sense that there was a real class distinction. On my mother's side, there was college education, and on my father's side, not at all. High school was the terminus. Growing up in the neighborhood we did, because of the residential segregation of the city of Chicago, went to an all-black elementary school for the first 3 years that was integrated in the sense of some white teachers and also a white principal at that institution. It was about third grade that it was determined that they really needed to move me out of the bedroom, which I shared with 3 sisters because I was getting older. So we moved up to a project. The project was wonderful in the sense it had an extra little bedroom, which was mine.
So this was a housing project. It was
a housing project.
By the city, or
No, in the city, Princeton Park, 9,300 or so. Well, it went from 90th to 95th. For those who know the city, Wentworth to Harvard. Yeah. Princeton Park was what it was called. The school for the district was one called Gillespie. Gillespie was totally black, teachers and students. And it was a wonderful experience. These teachers were really concerned about us. And I make a distinction there with respect to McCush, which was the name of the school they had gone to previously. So that, in some senses, the way it was. Oh, it should be mentioned that we were in a district for which the high school had been all white until Princeton Park was built.
Calumet.
Calumet High School, yes. And so I was about the third or fourth cadre of black students to go there. And that was a fascinating high school experience. Almost all classes, I'd be the only black student in them. But going back to this aspect of interest in chemistry, that started with radio. Listening to the radio commercials, better things for better living through chemistry. And then the through chemistry was dropped when chemistry got a bad reputation. Yeah. And so it was not until my senior year of high school that I actually had a chemistry course. I had physics as a junior and did well. We used to have these competitions where you stand up like a spelling bee and the instructor would ask questions, and if you missed them, you sat down. So I used to win those on occasion. And
so I know that's when your interest in sports was sort of either started or continued, right?
Oh, well, my interest in sports in particular, basketball, but football as well, began in Princeton Park. We moved out there. I must have arrived out there about my age of 8 or 9, something of that sort.
Okay.
And the way it was configured, that is the development, there was a large central area where you could play all kinds of sports. The local fire department would flood the central field, and we could ice skate in the wintertime. So we'd play hockey with brooms and sticks and all that sort of thing.
I seem to remember that you could skate on the Midway. Was that true?
You could skate on the Midway, but that was way north. And I was actually way north of where we were. And so I skated on the Midway when I was in college. But the early years, no, it was on this field in Princeton Park.
Right.
So.
Okay, so let's talk a little bit about later on. I know that you had this interesting series of experiences that finally led you to be educated at the University of Chicago. So can you
yes.
that a little bit?
Absolutely. When I applied to college, nearing, of course, completion of my senior year in high school. Every place I applied to that was a good four-year institution, I was not accepted into. And I was in the top 20 of a class of 370 students that graduated. And so my alternative, had I not gotten a scholarship, was the city colleges of the city of Chicago.
So you think there was a racial issue?
I have no idea, but let me expand on how the University of Chicago came about. Because through the normal application process, I got nothing. But it happened to be that there was a librarian at the high school who had endowed a scholarship to the University of Chicago.
This was Victoria, was that her name?
Victoria Adams was the name of the librarian, and of course Victoria A. Adams, as I recall, name of the scholarship. And there was a committee, high school campus committee.
On good progress in history, is that?
Well, let me
Okay.
let me talk about that for a moment. We did take a test, supposedly in history. This test focused totally on the Franco-Prussian War. Now, what did I know about that remains to be seen. So it was clear to me that this depended on what this small committee, I think it was three of them, three teachers, decided who should be awarded it. But it had been dormant for a number of years. And so three students in my class were awarded the scholarship, a white girl, a white guy, and myself. And so we went off to the University of Chicago. The white girl decided after a year the social life at the University of Chicago was the pits. And so she went off to the University of Illinois, Champaign-Urbana. The guy wanted to be a thespian, an actor, so he went off to UCLA. But for me, this was the only game in town. This was by far the best education I could get because my folks couldn't afford to send me. And my father had us solidly ensconced in lower middle class. He had passed the civil service exam in the mid-30s and was a mail carrier. And that's something, by the way, that I'm very familiar with because in about my junior year of college, I worked in the same place that summer. Dad said, "This is where I work. Make sure you do a good job here." "Yes, Dad, got it. But there's another story there in that respect. And so, actually, that summer, I made a lot of money. I threw a case, for those unfamiliar, carried the case, then drove collection afterwards. And so I was on the clock maybe 10, 12 hours a day. So it was very profitable. So good experiences, let me put it this way.
Okay. So talk a little bit about what happened after that.
After being admitted to the university, it was an eye-opener. To begin with, the first year in English course, and this is in the college of the University of Chicago. Of course, there is the college and then the specialties college, led to a PhD, that is a Bachelor of Philosophy, and what we used to say in nothing. Because what could you do? Go into the divisions, chemistry, physics, mathematics, and so forth. And but in that English course in the college, the professor went around the class asking us where we came from. And so it was very interesting to learn about all these places internationally where fellow students came from. So that was an eye-opener. And then my second year took Chemistry 1. Finally got to that and so forth. But also,
who should take it from? Do you remember?
What was his name? He was the secretary of the department. So I can't offhand recall his name. But the other aspect associated with my first year was I went off with the basketball team. And the University of Chicago's basketball team had the record of 1 win and 46 losses over the previous 3 years. And so we went out. There were mostly freshmen and one senior who went out for the basketball team. The senior became the captain. I fortunately became a starter that year, and to go through the undergraduate experience in basketball. The second year, I broke the scoring record, which has existed for X number of years. I can't remember what X is, and broke it twice before I finished. And in that respect, the single game record that I set was 42, broken in the three-point era. And when I was inducted into the Athletics Hall of Fame at the University of Chicago in 2004, the MC was a guy from ESPN who said I would have been in the mid-50s had the three-point rule existed back when I played. But to this day, I still have 2 records standing. Most field goals in a game, 19, and season average, 25 and a half. And I have some plaques associated with my induction into the Hall of Fame. So truly the most positive aspect of my undergraduate experience was basketball. Chemistry important and so on, but I have to back up in terms of the chemistry. Why? Because as a senior in high school, buddies said they were hiring over at the University of Chicago. So I went over in the employment office. They said, "Well, what can you do? Can you type?" "Oh, I just finished my junior year." And so they gave me a typing test on the spot. I did 32 words a minute but no mistakes. They said, you're slow, but you're accurate. We have two jobs. Cleaning monkey cages in the medical school at 88 cents an hour, or typing in physics at $1.09. So off I go to physics. And what do I find? Professor Robert Mulligan, as we well know, won the Nobel Prize somewhat 15 years after I started working there. I had no influence on that. And then it was an exposure to theory. In other words, I was over there to type reports to the funding agency, which was the Office of Naval Research. And I was doing this on an electric typewriter, an IBM electric typewriter before Selectric. This was a typewriter with interchangeable keys. The Greek alphabet, mathematical symbols, and all this sort of thing.
You had to switch them manually?
Absolutely, and they developed a large box where we put keys so you know which ones are in at the given point.
Sounds like slow work.
Oh, yeah, you pay the price. And I retained some of the reports I typed, and others did at that time, and I enjoyed showing those to new graduate students who would come to the group. This is the way it used to be, and this is what we did, and so on.
Okay, so let's talk a little bit about what happened after that, graduate school and so on.
Oh, yes, okay. Because of basketball, you might say, I did not blaze the top like I did in high school, but I did well. But there again, when I applied to graduate schools, similar to my experience in applying to undergraduate schools, no success.
I think it was harder to get in those days. I applied to Stanford, didn't get in, so maybe that was a general experience.
Well, don't know, since that was my only experience. But the then chair of chemistry at Chicago was Henry Taubbe.
Another Nobel.
Who later on, maybe I helped these folks along the path. I don't know. But in any event, he said, well, Lester, we'll let you stay, which was not generally done, to stay for an advanced degree at the institution of that quality, if you had your undergrad degree there. And so I said, absolutely. So I stayed, for a master's. And my master's project was under the tutelage of a guy named Stuart Rice. I know you've heard that name, who was at that point a fresh-faced new professor. And so he was actually very helpful in getting me admitted for doctoral studies at Washington University in St. Louis.
Was there an issue of not going on to a PhD at Chicago? They wanted you to go somewhere else? Was that?
Oh, yeah. Just let me stay for a master's, and that's it, that sort of thing. So no PhD was not in the cards for the University of Chicago.
So then you went to Washington University.
Went to WashU. I should add that in Christmas, mid-term associated with that particular academic year, I got married. And I hadn't planned on getting married. But before I left to St. Louis, my then girlfriend said, well, what about me? And I said, I have no money. I just have a teaching assistantship.
So that was Rochelle.
That was Rochelle. And so she said, well, I'll work, which she had been doing. She'd been a social worker in Chicago. So we did the calculation. And, okay, that will work. So we got married with that Christmas and so forth. And so forth means that within a couple of months, she was pregnant. So much for diaphragms and their adequacy, because I have had 2 diaphragm children before I finished my doctorate. Let me say this. But in any event, at WashU, I went to work for a guy named Weissman. I don't know if you knew Weissman.
I think so.
I'm trying to remember his name. Sam Weissman, yeah.
I think I've heard it.
Sam Weissman was one of the experts in ESR and EMR. And it was primarily electron spin resonance for molecules, yeah. And so I couldn't. And so I called the folks at Catholic University. The reason being that a research associate with Mulligan, and I was with that operation in terms of working throughout my undergraduate years, it said if you want to get a degree dealing with molecular orbital theory, quantum mechanics, and so forth in the chemistry department, there were very few, because Mulligan was in the physics department, of course, as I mentioned early on. And he said, but Catholic, where I got my degree, in chemistry, PhD, would be a good place to go. Oh, okay. So I'd applied to them. I'd been admitted, but didn't know that until after the April 15th deadline for responding to the institution you would go to. Why was it so late? Because my letter went to Dr. William A. Lester, head of student health, in a sanitarium in suburban Chicago. That was real. So, and I called Catholic, completion of that academic year, called Catholic, asked him if I could come, and he said, yes, I could. And so this I planned to do. But I also needed some income for that summer at the end of the academic year. And so I went around to 3 companies, Mallinckrodt Chemical, Monsanto, and Tri-City Oil.
But there was some reason you went to Catholic. There was a certain person you wanted to work for. Right?
Oh yeah, I was the research director for, this was one of the few women in theoretical chemistry, Virginia Griffing.
Yeah, right. So it was interesting, right? I mean, she had to be one of a very small number in those days, right?
Yeah.
Okay.
So, but that summer, when I discovered I couldn't find anything, there was a professor in chemistry, Lindsay Helmholtz. Yeah, well, as I mentioned, I called Catholic and they said, come on. Needed employment that summer, and this professor in chemistry at WashU, Lindsay Helmholtz, said, well, you can come and do some experiments with me. Well, mind you, my focus was theory, but absolutely it's paid money, so I'll do those. And the goal was to seed crystals of germanium hexafluoride with manganese. With manganese to get an ESR signal, okay? To precipitate the fluorides out of hydrogen fluoride, which you know how caustic that stuff is. And so I'm dealing with rubber gloves in a hood, trying to precipitate these crystals with a dopant, and then put them in an ESR spectrometer.
Is this what convinced you to be a theorist?
Well, let me tell you part of the basis of this. That for a full summer, I was putting beautiful crystals into the spectrometer. No signal. And I said to myself, I knew there was a driver for being in theory. So really, it was a very helpful experience, but it just cemented, my direction, my preference, which I already had a strong predilection to. There was no ifs, ands, or buts about that.
Okay, so let's talk about finishing your PhD.
Oh, yes. So here I am in a situation where I needed to get to Washington, D.C., so I bought a used car, had a U-Haul, piled everything in it, and with my pregnant wife, we went motoring from St. Louis to D.C., coming in on New York Avenue, and this other family came in on Pennsylvania Avenue. Their name was Kennedy, but the Lesters, we had a different name. We didn't converge, by the way, except later on, and let me indicate now when that was, that because of my financial hardship, the amount of money I was receiving at Catholic, I had talked to the fellow at Chicago who had suggested Catholic. His name was Bernard Ransel, Dr. Bernard Ransel. And he said, well, they have summer internships at the Bureau of Standards. Get in touch with this fellow, Morris Krauss, which I did. And he said, well, maybe he can do something for you. So I went out there and talked to Mo, is what we called him. And Mo said, yeah, sure, come on out. And so I did, and so on, and made some nice change that summer. And then back to campus to satisfy requirements. And so the following spring, he called. He said, would you like to come out again? I said, I have 2 children now. I really need to get out of school as fast as I can. He said, well, people do get their degrees, from here. Oh, really? So I went in and talked to my research advisor, Virginia Griffing. And Virginia said, well, Bill, what do you want to do? Get an education or earn money? And for me, that's, that's no dichotomy. No, I need to do both. Unfortunately, the way life is, she died of an aneurysm that spring.
Too bad.
And so off I went to the Bureau of Standards, and after that summer, went on the regular payroll. I finished my last 2 years of graduate work as a GS9.
Somebody must have had to sign your PhD then, somebody else?
Oh, yes. I was going to get to that in a moment. Actually, it was signed by a priest there, Father John Dooling, who actually taught the statistical mechanics course at Catholic. But there was another fellow who came in who actually was the reader. And I think actually he signed it being knowledgeable, Ying Nan Chu, who was a spectroscopist and whose wife was also a scientist. And he went on the faculty at Catholic and she went on the faculty at Howard University. But the main point here is that it was Morris Krauss who suggested the problem I worked on. And that problem dealt with something called correlated Gaussians, which were new and proposed by Francis Boys in a publication in 1960. And we're talking now 61 or 2 in terms of my being, 62 I guess it was, being at the Bureau of Standards. And so I'm onto this hot problem. And by the way, it's been cited many times subsequently. So we did 2 papers associated with it.
So was this connected with the eventual development of density functional theory? Or did that come later?
Density functional theory came much later.
No, but I think you said something about it being the groundwork for that. Or
it could have been. I can't say anything about that at all. No.
Okay, so let's talk about postdoc. University of Wisconsin, right?
Yes.
So again, we were there at the same time, I think.
When did you get there?
63.
Okay, as a graduate student, coming as a new graduate student.
I was really just a kid.
So I arrived in the fall of '64 as a postdoc with Richard Bernstein.
Sorry I didn't know you then.
Where were you? Where were you located?
In that at the time, the new building.
1112 Johnson Street?
I think so.
Yeah, what floor?
Boy, 6th, maybe?
Okay, I was on the 2nd floor. That's where the Theoretical Chemistry Institute was located. And Bernstein was a member of the Theoretical Chemistry Institute.
So I took kinetics from him.
Did you?
So it's probably the same time you were there. I wish I'd known you.
Well, I'm downstairs dealing with a brand new problem direction, separate, very different from my thesis. And this is dealing with internal energy states of molecules. And as you know, the Schrödinger equation, which is the big equation that one solves, and principle, if one can, to gain information on molecular systems, can be separated in terms of nuclear motion and electronic motion. And so the focus here was, that is nuclear motion being the atoms of the molecule moving and atoms and molecules moving with respect to one another. And the game that was of interest here was to compute rotational energy transfer by collision of an atom with a diatomic molecule. And so because this was computational, this meant the simplest ones you could consider. And the other part of it here, I guess our original case was to compute potential energy surfaces, but that became a sideline I dealt with later, and we can talk about that further. But the main point here was that it involved solving coupled differential equation systems. And in that regard, that was new to me. Ramped up on it, learned a lot about that sort of thing. Got to know a lot of the people in the Mathematical Sciences Institute, which you may have been familiar with, and was able to compute accurately the cross sections, expectation values for collisions of atoms, an atom with a single diatomic molecule.
So, the computer facilities, were they okay at the time?
Absolutely inadequate at
Wisconsin. Right?
At Wisconsin. Yeah. And as a matter of fact, used some of the computational facilities at the Bureau standards for what I needed to do. But then Wisconsin, then the university as a whole had a computer center in the physics department is where it was housed. And they had, at that point, a control data system. CDC 3600 was the first, followed by a 6400. And 2 years after I left Wisconsin is when the activists blew it up. Yeah, so it, one of those points. But in point of fact, within 8 months of my assuming the postdoc position, I was asked to assume the position of assistant director of the institute. And I told Bernstein, I said, Dick, I have a regular job. I'm on education leave. He said, take the job, Bill, take the job. Oh, okay. And I thought about it. Okay, so I did. And the first day I'm reading correspondence between the NASA program officer, it was a NASA-funded institute, and the director. Second paragraph said, you need to diversify. So bottom line, Bob, it was an affirmative action position. The guy who held the position went off to a regular job, faculty position elsewhere. Right. So, okay. But then I gave my talk to go on to faculty. And everyone approved of it, except the director of the institute, Hirschfelder. So Dick told me that. I said, okay. So I retained this job for a few years as the assistant director, but also became a lecturer, not on the academic step ladder at Wisconsin. And then they said, well, the money's getting tight, so we're going to dissolve your position. Okay, so now it's spring of 68. American Physical Society is meeting in Berkeley, American Chemical Society in San Francisco, a week apart. And so I took my family, brought them with me to the West Coast because I have a sister who was living in the Bay Area that we would visit for the week and so on. And furthermore, during that week, visit IBM Research. Well, why IBM Research? Because there were a number of guys working there who were graduate students or postdocs at the University of Chicago when I was working for Mulliken in what was called the Laboratory Molecular Structure and Spectra. And so I visited them. But furthermore, this was in a department called Large-Scale Scientific Computations, and then headed by a guy by the name of Enrico Clementi.
So he was really at the forefront of big computing in those days, right?
Well, he hadn't as yet,
Okay.
because when I met him is when he was a candidate for a position on the faculty and in the institute at Wisconsin. Why? Because the fellow who was in the office next to me, junior faculty member, and this is a fact, when Hirschfelder came to see him and said, my name should be on this particular paper, and the guy said, if you insist, I'm leaving. I'm going back to where I was before. So he left. He went back to Argonne National Laboratory. Then there began a search for his replacement, and fellows at all levels who I'd known by reputation and so forth came in, including Clementi, who at that time was on sabbatical at the University of Chicago because he had been there with Mulliken previously. So it's a tight little loop here. And so Clementi was saying, I'm coming. And one day he said, no, I'm not coming. What do I learn after I visit San Jose Research Lab, which is the IBM facility where he was located, that he had been using the idea of leaving IBM and going to Wisconsin as a negotiation ploy to get created the large-scale scientific computations division.
So that's how that happened.
That's how that happened. And when I visited, he said, I want you to meet someone. He took me down the hall and introduced me to the director of the laboratory and said, we're going to hire this guy. And then we get back to Clementi's office. I said, what are you talking about? He said, I know your work from when I was a candidate in Wisconsin. I mean, you can't make this up. And so I was hired there. And by the way, I should add, I was going to make a whopping $5,000 more a year. I would have all the computing resources I would need. I would be in California. And so it was, no-brainer. So the Lesters moved in 1968 to San Jose, California. I should interject here that a year and a half before moving, that winter, my daughter, who is now 5 years of age, in a 3-block walk from kindergarten to the house, suffered frostbite because she took her mitten off.
This was in Wisconsin?
Madison. This was a Madison winter, for which that day the high was 11 below. I'll never forget that temperature. She came in screaming. Anyway, that was one of those things. So
California was a pleasant change.
Yeah, and so I continued the research I started, in a general sense, at Wisconsin. Got a lot done, and that's when I established some of the standards by which others were able to calibrate their algorithms for the computation of similar sorts of things.
Okay, so let's talk about the next stages in your career. You were at IBM for quite a while, right? Yeah,
well, there's an interesting point along the way. I became a candidate for the fast track promotion, moving up the system. And so that involved spending a year on the staff of the Vice President Director of Research, at that point, Ralph Gomery. So we moved to White Plains, New York. Okay. And so my wife and I, we enjoyed it.
That was another IBM?
That was a separate facility. This is the headquarters of IBM Research Division. IBM Research Division was headquartered at Yorktown Heights, had satellite laboratories at Rüschlikon, just outside Zurich, as well as San Jose. And the Rüschlikon guys had gotten a Nobel a few years earlier in physics. But in any event, it became clear to me during the course of that year that I did not want to marry the corporation. I mean, that it would have been a totally different path for which, the science driver would not be satisfied. So, but we did like White Plains, so I asked Gomery, I said, we would like to stay here. Oh, no, chemists belong in San Jose. So I get back to San Jose. Things didn't work out too well there, did they? So it was clear to me it was time to move on. Now, in the meantime, the National Academy of Sciences had been doing a study of the creation of something called the National Resource for Computation and Chemistry, geared towards assisting chemists across the country and being able to better use computers. And furthermore, asking the question of subdisciplines of chemistry, how can computation advance this particular area? So I threw my name in the ringer for that, and I was selected, actually. It was at a time when the general view of chemists, and you may recall this, I don't know, who said, computer? What do you need a computer for? If you have a question, you ask a good chemist. They can answer that.
Especially in my area. Okay, let's talk a little bit about what happened later. Start with your interaction or running the NRCC, the National Research for Computational Chemistry.
National Resource for Computation and Chemistry,
Resource.
Yeah.
And how that led to the associate directorship at LBNL and eventually the Berkeley faculty appointment.
Well, actually, the issue here is that the NRCC was under contention by various national laboratories for housing. And Lawrence Berkeley Lab won that competition. And so it was cited at Lawrence Berkeley Lab. Right. And so this meant that I would have to travel from San Jose, where I live, to Berkeley, and I did that for a few months and came in and told my wife
not quite as hard as it is today.
Relatively speaking, it would be impossible today to even think about the concept. But in point of fact, in addition to being director of the NRCC, the position came as with being an associate director at Lawrence Berkeley Laboratory. There must have been about 8 associate directors at that time. And let's see, my appointment began in February of 1978. The concept of NRCC was approved in November of 1977. When I come in, what I am told is that this is to be a 3-year experiment, by the way, that there would be 1 year of funding and then we would be reviewed for continuation. I said, well, this makes no sense at all, because you can get nothing done in a year. So I have to hire a staff to do this sorts of things. I said, okay, we'll give you another year before we have the review. Okay, fine.
So I don't know if you remember, but that 78 was the year that I and Earl Mudrides got to Berkeley. Same.
Oh,
year.
really? Oh, no, I'm up at LBL, totally consumed by this mandate.
Anyway, we were both living in the same area.
Is that right? Okay. Okay. And so
I feel like I was following you around for your whole career. Because, I moved to Caltech the same time you went to IBM. More
oh, really?
Right. Yeah.
Oh, okay. Did not appreciate that.
Yeah.
Okay. Wow.
Okay. So
nice
anyway.
to know you. So, one of the main things, of course, with NRCC was to hold these workshops in which we'd ask the question and bring together the various folks in these various sub-disciplines. And so that dominated activity. Besides hiring staff, young people that work in the various sub-disciplines of chemistry. So they were to have their own research activities, which we supported and so on. And one of the guys I hired was a guy by the name of David Sepperly. David was someone that Bernie Alder, internationally recognized physicist, had said, Bill, you got to hire this guy and so forth. Well, I looked at his Vita and so forth. They looked good and so on. I did. And the reason that Bernie was pushing this is that David had been carrying out research in quantum Monte Carlo, that is for systems which are of a quantum nature to do also Monte Carlo calculations. And Bernie was an expert in classical Monte Carlo. And so David was carrying out research with Bernie while at the same time helping to develop the cadre of programs associated with statistical mechanics. One day, David came to the office and said that they had gotten 100% of the correlation energy for the electron gas. This is a model system in which consists of electrons running around each other. Correlation energy is the difference between the total energy of a system and the energy associated with something called the Hartree-Fock approximation, which considers each electron in the field of the n-1 electrons and does the average to get the energy. So on that basis, I said, well, you're not going to do that? Well, if this stuff is really good, you should apply it to atoms and molecules. But Bill, I'm a condensed matter physicist, though he was working in a theoretical chemistry institute, so to speak. I should say NRCC was, basically a theoretical chemistry activity. And so this became the point where there was a fellow who had gotten his bachelor's at Berkeley, a PhD at Boston University, who wanted to come back. And I said, well, if he wants to come back and work on this problem, I will cover those costs so we can see what this method can do. And he did. This is Peter Reynolds. Peter, subsequently, at the conclusion of NRCC, went on to become a program officer with the Navy and then subsequently with the Army and various activities of this sort, an outstanding scientist. But the main point, this first Atoms and Molecules paper, based upon a review of publications of citations by one of my graduate students maybe a decade and a half later, was the most cited paper, aside from the book we wrote in the mid-90s, regarding research that we'd carried out. Because it was new and people were interested, and the quality of the results that we got were better than anything around. So that was really a plus. And so on that basis, I changed my research direction. I said, if this stuff is that good, let me see what it can do for other atoms and molecules and molecular systems, computing barriers to reactions, structure of molecules, all of that sort of thing. So that became the focus. And that, in general, it was well received. A lot of people started to use the technique and so forth. And it led to my receiving some awards. The election to the International Academy of Quantum Molecular Science occurred some years later. Fellow of the American Physical Society, Fellow of the American Chemical Society, Fellow of the American Association for the Advancement of Science, various things of that sort, which you know all about this stuff. So.
Okay, so let's talk about your career at the University of California. Okay.
Yes.
That's how that started.
Oh, yes. Well, that dates back to when I was at IBM. Why? Because of two faculty members in theory for molecules at Berkeley, Fritz Schaefer and Bill Miller. They sent two students down to work with me. And these students were so good, I said to myself, no wonder those guys are so productive. Barbara Garrison, subsequently, when she finished, went to Penn State, became chair of chemistry at Penn State. The guy, Andy Raskowski, unfortunately passed some years later. So it told me something about the quality of students, graduate students who were at Berkeley. And so the thought of when NRCC was closed after a review, because the basis of continuation was that we were to be reviewed 2 years later, David Shirley, who you knew, and I agree that this was nonsensical. What they were trying to do was just bleed us to death, and they would kill us in 2 years. So why go through that? So it was closed. I should add that the NRCC was jointly supported by the Department of Energy and the National Science Foundation. And after our closure, the Department of Energy said, well, had we supported, well, it's supported by ourselves, we would have continued it. But the National Science Foundation sent out questionnaires to the chemistry community asking what the impact of NRCC had been after a year and a half, and most folks had not heard of it at that time. So that's just real.
Time.
Oh, it was ridiculous, you know.
And Dave Shirley was a lab director at the time, is
that? No, at that time, Dave, I think was
associate director.
Oh no, yes, he was. Yeah. No, he was director of Lawrence Berkeley Lab. He had succeeded Andy Sessler, who was the guy who hired me a year or two earlier. Keep that in mind for sure. Yeah, David was. Yeah.
Okay, so shortly thereafter you joined the faculty?
Yes, shortly thereafter I joined the faculty. Well, one faculty member said they would like me to stay. I said there's only one way I would stay, and then, there was consternation on that, but it was made to happen, and so I became a faculty member in chemistry, full professor.
Okay. What year was that?
That was 1981.
Okay, and so talk a little bit about both your, scientific activities at Berkeley and the other things that you did.
Oh, yes. Continued research with quantum Monte Carlo, applying quantum Monte Carlo to molecular systems and so forth. I should add in the meantime, in about 79, my son won a Regents scholarship and came to Berkeley and majored in electrical engineering and computer science. Finished in 83 or so. Let's see, about the same time my daughter won an IBM scholarship, Carey Award, and she went off to UCLA. Then continuing, my son, having come to Berkeley, he was involved with something called the Professional Development Program, which was to assist primarily students of color through the beginning course, in this case calculus and mathematics. And I liked what they did. Primarily, the students worked with each other of various levels to assist each other through this demanding course. The guy who was head of it initially was Yuri Treisman, who received a MacArthur for his work with PDP. And so it was in the early 90s I was asked to be Associate Dean for Undergraduate Affairs in the College of Chemistry. I accepted this, and my first thought was we should map that into the College of Chemistry, which was done. And so we had a College of Chemistry Scholars Program comparable to PDP and mathematics. And it was mid-90s when Neil Lane, who'd done similar work, who was at that point director of the National Science Foundation, asked me to come back and work with him on their diversity issues. And so I went back and I had the title Senior Fellow for Science and Engineering and Assistant to the Director for Human Resource Development. This is the longest title in the world. Okay.
So you had to take leave from Berkeley?
Absolutely. I was I did not take leave.
No, you didn't.
There's something that is called with the government IPA, Intergovernmental Personnel Act. So I maintained my continuity with campus. So lost no time, though I was physically in Washington, D.C.
You still have to teach or not?
Oh, not at all. I'm totally in Washington, D.C.
Yeah, okay.
But I am not on leave. I'm going to make the technical distinction. Because that is, an issue in terms of people going to work for the government in that respect. And so that was interesting. We did what we could and so on. But Neil said, "Oh, well, you've got you in the government now." And I said, "No." Well, after a year or two, I said, "No, I'm going back." And I needed to go back. Excuse me, if I was to maintain my position in Berkeley.
Neil became science advisor?
He became Clinton's science advisor, yes. And we would go to the Hill on occasion, and it was interesting, walking around the Hill, doing things, talking with the various folks. And I have some pictures, Rochelle and I, not with Clinton, but with others in the government at that juncture. So it was an interesting, broadening experience, no question about that.
So talk a little bit about, I know that you've been involved with intercollegiate activity, athletics on both the campus and national level, right? So
No, this is primarily campus. I was every institution which engages in sports sanctioned by the NCAA as a faculty athletics representative. And so I was asked to be faculty athletics representative. Why? Because the fellow who was my predecessor had asked the campus to vote for no confidence in Chancellor Berdahl, chancellor at that point. And so Berdahl said, I'll have nobody work for me who does not support me. So he let Citron go. In any event, so I became that. Held that position from 1999 to 2004, but in my initial year, my name appeared on the front page of the San Francisco Chronicle because I had approved two guys as being eligible, and it turns out
eligible for like football or
football, exactly, yes. Eligible for football, and turns out they were not. My basis of approving them was that I had talked to the professor who had provided them with passing grades. It had nothing to substantiate that investigation by the Pac-10.
There was an academic requirement for the football players, is that?
For everybody.
Yeah, okay.
Right.
Sorry, I don't know a lot about this.
This is just, you just have to pass your courses.
Right.
The point here is simply that, I won't go into the that. We can talk about that off scale or offline. But in point of fact, there was an investigation by the Pac-10. It was Pac-12 now. And the faculty member could not come up with data to support the grade he provided. And here I had approved them for intercollegiate athletics. The University of California, Berkeley was declared institutionally irresponsible because of moi. So I had never had the experience of not getting the truth from my professional colleagues. So this was an eye-opener. So people...
Is there any reason... you think this guy was paid off? Or
he
just loved football?
No, I think he wanted to be helpful in terms of diversity issues.
Yeah, okay.
Okay, and he sort of leaned over the wrong way. And Berdahl said he understood it all, and what
was the resolution of that?
But even before that, the reason that there was unhappiness by the previous faculty athletics rep was that Berdahl had approved, I think, some 7 or so FTEs to ethnic studies. Okay, and that was the core of the issue that led to the problem of calling for a vote of no confidence in him and all that sort of thing. So
let's talk a little bit about your interactions kind of in a local level in the chemistry department, maybe the physics department if you had some. I'm thinking specifically of you had some really good colleagues in the theoretical group.
Oh, yes.
So maybe you can talk a little bit about your interaction with those people.
I did mention early on that Fritz Schaefer, who subsequently went to the University of Georgia, and Bill Miller sent a couple of students down to work with me when I was at IBM. Both outstanding scientists, Fritz for electronic structure and Bill for collision dynamics. That he is widely recognized for. So, excellent people. My next door neighbor is David Chandler, and David is an institution in his own right, we say. Other theorists, let's see, who comes to mind again? I mean, those are really, that's the core of
those days anyway, right?
Yeah.
And you had some...
Oh, I should mention my fellow University of Chicago graduate, Robert Harris.
Oh, sure.
Bob Harris came to Chicago, by the way, my last year as an undergrad. We were in class together, and subsequently, and we both had the same advisor. My master's advisor was his PhD advisor. And so he was on the faculty, of course, for a number of years before retiring some years ago now. And I did retire some years after the normal retirement age.
It's become not so normal anymore.
Right. And so excellent group. I think the excellent set of deans. I think Bradley Moore was the dean when I went off to NSF. And I think Clay Heckcock later became dean of the college.
Was chair for a while.
Yes. Yeah.
So it was always a very strong group, I think, right?
Oh, a strong department.
Yeah.
Of course, you know where our department is recognized internationally. Number one, folks, in case there's any question.
Right. But I mean, the theory group has always been real.
It does, very strong, very strong. Yes.
So you mentioned, becoming an emeritus professor. So tell us a little bit about what your thinking was about when you decided to become emeritus, or what
Yes,
your
okay,
pros
be
and
happy
cons
to.
were.
My deciding to become retiring was after my wife passed that March.
I'm really sorry.
I retired, and then I was asked to be a professor, to come back. I guess professor of the graduate school, I think, had been created at that point. And I still had postdocs and even a few students who were around. No, I hadn't taken a student for a couple of years because whether I could see a student through 5 years, which was typical in terms of my kind of research, remained to be seen. So I just dealt with postdocs up until, beyond age 65. Okay.
Do you have any concerns about retiring, or was it kind of a normal? Did you feel it was a normal transition?
I hadn't thought about retiring until Rochelle's demise. I mean, and that's what shifted my whole focus and so forth. But I still had interest in doing things, and so that's why becoming professor of the graduate school was valuable. And I had some very good postdocs who came in after that. I mean, who have gone various places. As a matter of fact, there was an undergraduate from Morehouse College who came in 2011 who was going to come to Berkeley to graduate school. Also was a feshriff for me in 2007, a guy I worked with at IBM in the mid-'70s. He wanted his son to come and work with me. But they were caught up in the big vacuum of this outstanding graduate student I had, Alain Espero-Guzik, who got an appointment at Harvard, and all these guys went off to Harvard. And Rochelle said, well, that's good. This is your students where they're going. And I had to laugh. And so, in point of fact, it was just this summer that I got this email from the student, James Whitfield, and we met and we talked a bit. And reading Sunday's New York Times about quantum dynamics and computing, Whitfield is cited in one of the paragraphs. I just sent off an email yesterday. James, I'm reading about you in the New York Times business review section.
Wow.
So you look at your predecessors, who's involved, and all that sort of thing. So delighted with his success, because another undergraduate who did very well, did some research with me, went off also to work with Alain. I mean, now I'm doing this counting, who did this. And he has since come back to a postdoc at LBL. I'm not sure where he is at this point. But he was really an outstanding undergraduate student here. I mean, and we have very good undergraduates, but this guy was, lock, stock, and barrel up there. So all of this was very good. I think made possible because of the quality of students we get at this institution. So impressed.
You've seen a lot of people come into Berkeley and rise through the ranks
Yes.
and so on. If you had some advice to give to young people who are starting in theory today, you want to say a little bit about that?
Oh, I would like to back up in terms of young people, not just in theory, but pursuing what they are interested in. And I hearken back to my experience at IBM, being on the staff of the vice president and director of the fast track, that I decided that was not for me. And I'm sure many people would have jumped at that opportunity. So my first advice, even before you talk about theory, but if it is theory that you want, then pursue it. And pursue it in the direction that your inclinations take you. No ifs, ands, or buts about that. Not that what others would say was good and so forth and so on, but that what you, in your gut, as you well know, view to be that direction.
Yeah, there is this
which holds
issue
interest.
about, a lot of young people, want to know whether there's a practical impact for what they're doing or not, or something more fundamental.
Well, I would argue that there's always going to be a practical impact on good stuff, because you can't anticipate. But if you see a direction that you can advance, there will be benefits that happen, that occur, that you cannot anticipate. So I think the discussion with young people who are concerned about this is to indicate to them that if you can contribute fundamentally to an area, there will be benefits more broadly to society as a consequence of making advances in that area.
I would certainly agree with that.
Yeah,
I guess one thing I'd be interested in is whether you had any sense that being an African American had an impact either on your appointment or anything that happened to you later?
Well, deep down, I suspect probably there was some of this, but that had nothing to do with the appointment. I think it was just general background noise, so to speak, of being an African American, and I also don't use African American. I use Black American because I know white African Americans.
True.
And so, no, nothing out of the ordinary in that respect. That it's always difficult to achieve these appointments, and was pleased. I had been asked by some members of the department to stay, and I said, there's only one way I would stay. I think they were thinking of my staying at LBL, and no, I did not want to do that. In terms of doing research and that sort of thing, IBM offered a better environment in that general regards versus LBL. But if you have LBL and the campus, then that's a different ball of wax. So.
My recollection was that it was George Pimentel who was sort of the prime mover in proposing you to the faculty. Does that ring a bell?
No.
Yeah.
I met George in 1968 when I visited the campus and prodded by people in University Hall and the administration. And I visited, and it was said that there were a lot of good people who applied, and that's when I went in '68 to IBM. Okay, and it was a decade later, or so, that I ended up coming to the faculty.
Yeah.
Peculiar aspect of history.
Yeah. Okay.
Well, thank you, Bob, for taking the time to
I'm really
do this.
More than pleased that I could do this, Bill, because we've been colleagues for all these years, and there's so many things that I didn't know about you and your career, and especially about the times that we were in the same places, sometimes without knowing it.
Right.
So for me, it's been a really enlightening
The silos of
experience.
chemistry, should you always say.
Right. That's right. I think that's a good example. So I've had a really great time, and I'm more than grateful to be able to act as your interviewer.
Well, good. Thank you.